We are discussing the ISI 2023 BStat paper today, and this is question number 8. It says how many numbers formed by rearranging the digits of the given number 2, 3, 4, 5, 7, 8 are divisible by 55. Now, if a number is divisible by 55, then the number has to be divisible by 5 and 11. Now, if you look at the digits are 2, 3, 4, 5, 7, 8. So, if the number formed by rearranging this 6 digits has to be divisible by 5, then the last digit has to be 5. Now, let us see how we can arrange the other digits. So, let's say that other digits are A1, A2, A3, A4 and A5. Now, if you look at the digits, if I take 2 plus 3 plus 4, this is 9, and 5 plus 7 plus 8, this is 20. So, the difference between these two is 11. Now, we know that if a number has to be divisible by 11, then you add up the digits in the odd place, you add up the digits in the even place, take the difference, and that difference has to be 0 or a multiple of 11. Now, this is one way in which we can get the number divisible by 11. So, which means that one set of the numbers has to be 2, 3, 4 and the other set has to be 5, 7, 8. So, therefore, one of the numbers is 5. So, therefore, A4 and A2 has to be between 7 and 8. And therefore, A1, A3 and A5 has to be one among 2, 3 and 4. And A2 and A4 has to be among 7 and 8. Now, this is one combination. So, that means I can arrange 2, 3 and 4 in factorial 3 ways. I can arrange 7 and 8 in factorial 2 ways. So, therefore, the total possible permutation of these numbers is factorial 3 into factorial 2, which is 12. So, if I go with this combination 2, 3, 4, 5, 7, 8, then I will have 12 numbers which are divisible by 55. Now, if I try to rearrange this again with some other combination, now the last digit is 5. Now, with 5, if I take 7, and with that, if I take any other number other than 8, let's say 4. So, this gives me 5, 7, 12 plus 4, 16. So, then the other numbers are 2, 3, 8. 2, 3, 8. This adds up to 8 plus 3, 11 plus 2, 13. Now, this difference is 3, which is not divisible by 11. Similarly, if I do 5, 7 and 3, that gives me 15, and I do 8, 4 and 2, and that gives me 14. Again, this difference is 1, not divisible by 11. And then I can try 5, 7, 2, which gives me 14, and then 8, 3, 4, which gives me 15. Once again, the difference is 1, not divisible by 15. You can also try the other combinations 5, 8, 2, which is 15, and 7, 3, 4, which is 14. Once again, not divisible by 11. You can also try 5, 8, 3 and 7, 2, 4. 5, 8, 3 gives you 16 and 7, 2, 4 gives you 13. Not divisible by 11. And the last combination that you can do is 5, 8, 4 and 7, 2, 3. So, 5, 8, 4 gives you 17 and 7, 2, 3 gives you 12. So, this is 5, not divisible by 11. So, none of the other combination is going to give you a number which is divisible by 11. So this is the only combination that will work to give you a number which is divisible by 11 and 5 both. So there are 12 such numbers. Now we move to the next question, which is question number 9. So this question says, let S and T be two given sets. How many elements does S intersection T have? So you see that S is defined as theta into sine pi theta by 1 plus theta and 1 by theta cos pi theta by 1 plus theta, where theta is a real number and is positive, and T is given by xy, where x into y is half. So if I have to have an element which is common to both S and T, so let that element be xy. Now that means xy has to be part of T and S. So if it has to be part of T, then xy has to be half, and if it has to be part of S, then let x be equal to theta into sine of pi theta by 1 plus theta, and y be equal to 1 by theta into cos of pi theta by 1 plus theta. So therefore xy will be, you multiply these two, you get sine of pi theta by 1 plus theta into cos of pi theta by 1 plus theta, and this is equal to half. So therefore you get 1 equals 2 sine of pi theta by 1 plus theta into cos of pi theta by 1 plus theta, which is of the form 2 sine x cos x. So this is sine 2x, which is sine of 2 pi theta by 1 plus theta. Now sine of 2 pi theta by 1 plus theta is equal to 1. So therefore you can write that this is equal to sine of pi by 2. So therefore 2 pi theta by 1 plus theta is equal to pi by 2 plus 2 into n into pi, where n is an integer. So now you divide both sides by 2 pi. So you get theta by 1 plus theta equals 1 by 4 plus n. So that means n becomes theta by 1 plus theta minus 1 by 4. Now we know that theta is greater than 0. So which means that theta by 1 plus theta will lie between 0 and 1. So that means n will lie between 3 by 4 and minus 1 by 4. So n lies between minus 1 by 4 and 3 by 4, and n is an integer. So there is only one value of n, which is n equal to 0. Now therefore the number of elements of S intersection T is 1, which is given by n equal to 0, and for n equal to 0 you get the value of theta as you can get it from here, theta by 1 plus theta equal to 1 by 4, or 4 theta equals to 1 plus theta. So theta will be equal to 1 by 3. So for theta equal to 1 by 3, you get x as 1 by 3 into sine of pi into 1 by 3 by 1 plus 1 by 3, which is 4 by 3, which is 1 by 3 sine of pi by 4, and similarly y will be 1 by 3 cos of pi by 4. So this will be the solution for S intersection T.